It's been nearly a year since my last Minecraft and Roblox video, and honestly, a lot has happened since this version. In fact, I have a whole new version that I'm about to show you in a second. And while a year is actually a very long time, I'm very glad I took this break because Roblox added a lot of features that are seriously useful to a game like this. So here's what the new prototype currently looks like. At first glance, yes, it probably looks worse, but if I start talking about the technical aspects behind it, this is like at least like 10 times better than the old one. It is like 20 times more efficient, no lag spikes, greater render distances, bigger chunks. There's a lot of good stuff to say about this, and I'm gonna go through them one by one. So the first big feature Roblox added is called editable meshes and editable images. If you're familiar with the old version, what we did is we created a block for each and every single part and then decided whether or not we should add a texture to each side. However, this is kind of inefficient because we're still rendering this face down here even though it would have been here and it's clearly not visible. And so in the new version, only the sides that are bordering the air are actually rendered using editable meshes. Plus, instead of having a decal for each and every single side, each chunk is a singular mesh and each chunk has a single image. And that image is simply a Minecraft texture atlas, but it's actually a texture atlas I created myself. I promise I did not rip this off because in the new version, everything's gonna be original, but this is just a downscaled version of like a texture pack. It'll change later. And the next big feature Roblox added, and honestly, I think this was released at the same exact time, it's called a buffer. And a buffer really just means like a block of memory that you have reserved, and you can write and read whatever you want to that block of memory. And now that's sounding awfully similar to tables or arrays. So let's say this is our table. This number is actually going to use 128 bits. So if you're adding a bunch of block IDs, let's say like 555, then that's 128 plus 128 plus 128 bits of memory. But you don't need 128 bits of memory to represent this number. What if we simply used 8 bits? And so instead you can just create a buffer and you can specify how many bits it should take up. Actually, I don't know if it takes bits or bytes. It is bytes. So we can specify that it takes up 3 bytes, and a byte is 8 bits, by the way. And then using the write u8, which just means an unsigned integer that takes up 8 bytes, we can do write to the buffer with no offset and then the value we want. So what we just did is essentially represented a table but just using a buffer. So instead of using 128 bits for each and every single block ID, we're only using 8 bits here, which made the block memory usage go down from about like 64 megabytes to 4 megabytes. Obviously, this depends on the render distance. However, this is a 16-time difference. That's huge. And the last important feature that I started using, and this was out back when I was making my own version, but the issue was I really didn't know how to use it, but now I do, thanks to taking an operating system class. You can speed up your generation by like quite a lot, and this is Roblox's example, going from 60 millisecond frame time to 17, which is huge. And I'm gonna show you a real comparison, a one-to-one comparison of the performance of this game versus this one. So the way I'm gonna do that is simply by setting the chunk size to 8 and the render distance to 10 for both games, and then using the micro profiler, we'll see which one performs better. And in case you don't know how the micro profiler works, that's completely okay. Just know if one of these orange bars goes all the way to the top, that's bad. That means that your frame has lagged, and that's basically a lag spike. And here I set it for the second game. And now we're gonna start the test. We're gonna start off with the old Mineblox, the one you may be more familiar with. And there's the micro profiler, and as you can tell, it is really laggy. I mean, look at all those bars. What is that? I mean, literally all of them are reaching the top. So this is pretty unplayable, and that's why I didn't really continue working on this game. It's because I could add more features to it, but like I could never release it since it's this optimized. And I'm running this on a pretty like strong computer, yet it just cannot handle it at all. So obviously a more optimized solution was required before I'd add any new features or anything. And now here's the new version, and I mean, just look at that. It's running perfectly. And I'm gonna get into this later, but it's running this well, even though the terrain generation is actually more advanced than the old one. And I'll get into the details later. I'm not sure if the terrain actually looks better. And also, I'll just focus on the terrain shape here. I know there's no trees yet. I'll be adding that in this video, hopefully. But the shape should have more variety. I mean, this area is a bit flatter than where we were. It was a bit more mountainous over there. And yeah, overall, it just runs smoothly, pretty amazingly. And initially, there was one problem with using editable meshes, which is that they don't actually have collisions, and I had to create my own collision system. Over here you can see it being highlighted in the green, so whenever I get close to a block, they actually snap to the block's position, and I'm using parts for those. So if I go ahead and select all of them, that's what they look like. So when they're invisible, you can't tell, but it's a really strange solution, I know, but like that's what I had to do. But it's honestly not that big of a problem. I mean, even mining works actually. And now you may be wondering, why do the textures look so terrible? In fact, that's probably the worst thing about this version, the only bad thing about it in my opinion. And the reason for that is because each texture is like an 8x8 image. However, what Roblox does is they upscale it using an algorithm that blurs it. I think it's a bicubic algorithm, I'm not fully sure. And while this might be a deal breaker for many people, I'm pretty confident eventually Roblox will add a new option for how these textures are upscaled. Because over here we have like every single algorithm. If we assume that this is the original picture and you upscale it the Roblox method, I'm not sure which one it is, but it would be blurry. But there's this one method called the nearest neighbor method, which actually retains the pixelization. So I'm just hoping eventually Roblox is going to add that to editable images or something along those lines. I mean, the performance is just too good. And now you might be wondering, how did I improve the terrain and what do I mean and what changed? So in the past, I just used simple Perlin noise. And if you're wondering what that looks like, this is what normal Perlin noise looks like. This is what I was using, I think. And I combined it with something called the squash factor, which just squishes things. So you have like caves and like, actually not caves, but more like overhangs and cliff. But what if we overlaid this Perlin noise layer with, let's say, a more refined one? Perhaps looks like this. Maybe we could combine them because this one is more detailed while the other one was more general, if that makes sense. That definitely does not make sense. Anyway, so the reason this place exists that I made is because I had to recreate these 5 noise maps that Minecraft uses for continentalness, erosion, peaks and valleys. And these 2 at the bottom are used for biomes, which I'll get into later. So I really had to create something to visualize how to create the noise. And Minecraft actually uses more than just noise. They use something called spline maps, which is why this doesn't exactly look like Perlin noise, even though it actually uses it. So these are the spline maps that Minecraft uses for continentalness, erosion, and peaks and valleys. So you can think of it like this. We can start off with some sort of Perlin noise value, let's say for continentalness, and then we can plug it into these graphs on the x-axis where it says continentalness, and then it'll return a terrain height. And then we can apply the same idea to both erosion and peaks and valleys, and then we can combine them together to get our desired terrain shape. And I'm not gonna lie, that is pretty complicated, and it's definitely gonna take a lot of playing around with to get the terrain looking exactly right. But what's important right now is these systems have been implemented, and it's only like the knobs that need to be tweaked. So I'm not gonna lie, it has been a month and I did do a lot of work, but for the other half of the month I was sort of on vacation. And now I've run into a bit of a problem, and I guess it's kind of apparent by like seeing there's no grass here. And I've been trying to figure it out for so long, and it's just not clicking in my head yet. What I'm basically trying to make is a system where like if you have this chunk, would be able to modify this chunk and also be able to modify this chunk. But each chunk is at a different step in the generation process, and they all need to be aligned in a certain way. So when a grass block is placed, it needs to communicate with the other chunks that it's neighboring, that the blocks below it. The grass block would need to be dirt. I don't know if that makes sense. And I'm not gonna bore you with the technical aspects of it, but the reason it's necessary to create such a system. Also, what is that? What is going on here? Yeah, honestly, I might have to revert this to an older version because it was honestly working better. But what I'm gonna do now is I'm actually gonna open source all of this code, which means all of you guys are gonna have access to all this code. And to access it is just gonna be a link to the GitHub. And I had already posted the last version of Mineblox onto the GitHub, but this is a completely new version, so I'm gonna update everything here. So if you'd like to mess around with this, just head over to the GitHub and then go to releases, and then you can download the RBXL file and import it. And feel free to actually contribute and add on to my code, because I mean obviously it does have, oh my god, why is this happening? It does have some issues, and if you want to add anything, feel free to, and I'll review it on the GitHub, and I might add it to the main code base. And leave a star while you're at it so that more people can see this. But anyways, I'm gonna try to revert this to an older version where things weren't as broken as they are now, and that's probably gonna be it for today's video. Okay, so I found an older version that's actually working more properly, and I'm not gonna lie, it's been so long since I've last worked on this that I don't even know the difference. Like, well, why is this working and the last one isn't? But I'm just gonna go with this version.